Seems like we get to do all my favorite lessons in this section. We got the trigonometry. Now we get to do limits of piecewise functions. And I don't know why, I just really like piecewise functions. So what is a piecewise function even talking about? So let's look at this first example. And let me just put it in Desmos just so you can kind of get a visual of what's going on. So we have 2 to the x. But they're going to restrict the domain from 0 to 4. So if I zoom out, you can see it's just a piece of the function from 0 to 4. Now technically, remember this is less than, not less than or equal to. So what that would look like if you were to actually look at it truly on a graph, you would put that as an open point, and then because this is equal to, it would be a closed point. And then we also have 8 square root of x. And that is for values greater than 4. So I'm going to put x is greater than 4. So I'm restricting that graph, and you can see it just keeps on going and going and going. If I keep zooming out, it'll just keep going, because that's going to exist on the domain of all x values greater than 4. So remember, this is the x-axis. This is about where x is 4, right there, see? And everywhere to the right of that, all values greater than 4, this function exists on it. So then that's an open point. It seems to meet, doesn't always meet. And so the graph will go like that. So how does this limit work? We're going to break it down to a left and a right hand limit. By the way, this is the one time you might see the jump algebraically, or actually one of the 2 times. There's one other special case, we'll see that later. But this could possibly cause the jump because it may not actually start right there. It may start up here. So we have to check both the left and the right hand limit. And I'm actually going to keep the graph. Let me go ahead and keep the graph. Didn't mean to do that. Use that as reference just for an understanding for us. That right there is where x is 4. That's our x-axis. All right, so let's do the left-hand limit. We're going to approach, its limit as x approaches 4. So for the left-hand limit, so what are we going to use? You got to figure out which of the 2 functions is to the left of 4. So this is x is greater than 4. Well, numbers that are greater than 4 are going to be to the right of 4, right? So if you think of that on the number line, let's just say this is 4. X is greater than 4 would be talking about to the right. This is where x is greater than 4. And then between 0 and 4, that would be right here. This is where x is between 0 and 4. So the left-hand limit would actually be coming from this function here. So we're going to use the 2x when we do this one. So the left-hand limit is going to be 2 to the 4, which is 16. And then the right-hand limit, we're going to use this one because it represents the right of 4, greater than 4. So from the right would be the 8 square root of x. So that would be 8 square root of 4. Which is 8 times 2, which is also 16. So you just need to double check, are the left and the right the same, unless they specify, which they could specify, in which case you just go with one of the limits. But since they're both the same, this limit, as x approaches 4, is 16. Now instead of LHL, it's probably better if you actually write out limit as x approaches 4 from the left like that. That would be a much better notation. Like I said, if you're in the AP test. This one's a similar example. I'm just going to go ahead and do that notation. So the limit as x approaches -2 from the left of h of x. So we're going to use this because this represents the left of -2. X is less than -2. So that's going to be 5 times -2, which is -10. Then as x approaches -2 from the right, it's going to be the other one. So from the right is going to be the values greater than -2. So this is the function that's on the right-hand side. If you were to picture that graph, it would be something like this. You know, some linear equation with an open point from the left, right? It's open and then it's closed on the right. And we don't quite know if they're going to meet. We're going to check that right now. So we're going to plug the -2 into the x cubed minus 2. which gives us negative 8 minus 2, which is negative 10. So they are both the same. So the good news is they actually do meet. So I'll just lasso this and bring it down right there. Boom, they actually meet. And so our answer then, the limit, as x approaches negative 2, h of x is negative 10. Let's look at this one. Got a natural log in there. So if you don't know about natural logs, you may want to Google them, do a little bit of research. They're pretty simple though, just inverse exponential. So we'll talk about that right now. So the limit as x approaches 1 of f of x. Now think about this. If I'm going to split this left and right, well, this isn't the left of 1 or the right of 1. This is the left of 0 and the right of 0. Think about the split then. This function is splitting to the left of 0 and to the right of 0. But 1 exists right here. 1 is existing in this green domain right here. So we don't even have to check the left or the right side of this because it's just existing right there, all within that green section. If it was right on the split, if they were asking like as x approaches 0 right on that split, then we would have to plug it into both and make sure that they're the same. But in this case, we're really just rolling with natural log because 1 exists in the domain of greater than 0. It's not doing the split right there. So once again, if this instead, let's just say if these instead were 1, then you would have to do the split. Or if this was 0, then you'd have to also split it up and do that left and right hand limit. But since we're just doing limit as x approaches 1, that exists all within this domain. So we're just going to use that natural log. So we're going to do natural log of 1. So when you see natural log, you're thinking e to what power is 1? Well, anything to the 0 power is 1, right? So our answer is 0. Natural log of 1 is 0. The two natural logs you got to remember is natural log of 1 is 0, and natural log of e is 1. So if you're in pre-calc watching this video, since you're going to get the same video, those would be kind of the two key ones you'd run into if it's natural log. You just substitute that in, and that's it. This is a very similar example. Negative 3 exists not in this domain. Notice it's splitting at negative 2. So we see this function split at negative 2, not at negative 3. So let's just figure out, is negative 3 between negative 2 and 1? No. Is it less than negative 2? Yes. So it exists in this domain, because if you look at the domain, let me just draw a graph again. So x is less than negative 2 is this way, and we also are concerned about negative 3. And then between negative 2 and 1 is right there. So we're really evaluating the limit over here, all within this domain. It's not where it splits. If it's where it splits, like we see up here, both of these are negative 2, we want that limit at negative 2, that's where it's going to possibly split, then we have to check both the left and the right hand limit.